Welcome again to another edition of the Southwest Climate Podcast, the first 2017 edition. I'm here with Mike Crimmins.
Happy New Year.
So I'm looking forward to another exciting year of climate. And, you know, we have a turn of the season sort of edition here. There's been a lot of change in recent weeks, if you will. California got pummeled and looks like their string of dry years may be over. So
you're
that's
calling the
change.
drought over?
Well,
you heard it here first, folks. Drought's over in California.
What are we in? Are we in a La Niña? I don't even know.
It's funny. It's like for Christmas, all I wanted was an El Niño winter, and I got it. But I got it a year too late, and I got it during a weak La Niña.
Yeah, well, you know, last year we had a La Niña for an El Niño, and this year we have an El Niño for a La Niña.
I know, it's all very confusing.
So there's a lot of change. So we've got a lot to cover. We'll probably release this podcast after a nice storm event hits Arizona.
A triple puncher.
So we got all that stuff to talk about. But Mike, how you doing?
I'm good. It's been raining. It's been cold. It's been snowy up on the mountains. There's been clouds. I've gotten to wear a jacket, which I don't often do.
Where should we begin? What do you want to talk about?
Begin at the beginning here.
All right. Well, so let's look at precipitation over the last month or so. If you look at the southwest area, the amount of precipitation has been pretty high across the entire swath of the Southwest. Arizona, New Mexico, basically from central California all the way down, talking precipitation amounts on the order of greater than 200% of average. So it's been a pretty active last month. And California, for the most part, has been that epicenter. I'm sure many people have been hearing about the widespread flooding, the 19 feet of snow on top of Mammoth.
The snowpack has been amazing to watch accumulate, especially over the last 5 years when they couldn't buy a snowflake. And now they get it all in a series of storms and stack up, near record depths across parts of the Sierra.
At least across the West Coast, the sort of active storm system sort of began around a little bit before actually Christmas.
Mm-hmm.
And they've continued, quite frankly. And we talked about last time these atmospheric rivers, and there's been a steady string of storms. What's been going on regionally?
We talked about last month that we were dealing with a La Niña advisory. So we'd come off of last year with the El Niño that didn't quite deal out the cards that we expected here across the Southwest. Ended up having that unbelievably warm and dry February-March period last year. And that was during El Niño. So we got kind of thrown on our heads. This year, we transitioned into La Niña in the spring and then through the summer, and had been kind of hanging and bumping around with this weak La Niña system. Having this La Niña staring us in the face for the upcoming winter really got us nervous. Coming out of a strong El Niño with, not great precip, especially under what we would expect for an El Niño, and then looking at a La Niña winter would have been a back-to-back drought winter situation. We knew that the La Niña was weak. We knew that its expression in the atmosphere was not very coherent. The sea surface temperature pattern was, it was there, but the atmosphere didn't seem to care. So we were kind of uncertain. What I expected, with the La Niña is that you start to see these high pressure systems and these ridges and these kind of endless sunny days and reasonably warm conditions in the middle of summer block out all those precip events. And we haven't seen that. It's been a highly changeable, very, very active weather pattern, even going back to the beginning of December. Across the Southwest here, now we're stacking up. Tucson already has recorded precip on 18 days since the beginning of the water year in October, and almost all of those have occurred since December 1st. What we normally see for an entire season all the way out through the end of May is about 25 days. So just on the frequency of precip, we are way ahead of average. The interesting thing is precip total-wise, at least for Tucson here, we're just slightly below average because a lot of these events have been very, very light. But the frequency of them has been remarkable.
Yeah, and that's been, not just here in Tucson, but it's been sort of region-wide. Maybe one of the sort of positive outcomes of the flooding has been the amount of snow that's been, packed in our basins, which really sort of bodes well, I think, for stream flow conditions and, the states of our reservoir. If you look across the West, actually here in Arizona and New Mexico, we are still running at slightly below average in some basins, although that's going to change with this upcoming storm system that's going to come this weekend, and we'll probably release this podcast after that. But there are some forecasts out there calling for as much as, in the low 40s in the inches in some of the high country. So while some basins in Arizona are slightly below average, that situation will likely change. However, if you move north into Utah and Colorado and even up into Wyoming, I mean, it's painted in above average.
Yeah, it's in the Intermountain West. You go from the Sierra of California all the way straight across Nevada, Utah into Colorado. It's a good solid, 150 to 200% of average snowpack for the middle of January. Again, it's kind of the middle part of the season. It's not peak snowpack, but that's pretty darn good.
Yeah, we're starting off well.
It's good. It's a really good thing. And, just to put a little finer point on the Arizona thing too, is it's interesting. If we look at the Arizona basins, all of the Arizona and New Mexico basins so far have observed average to above average precipitation, but these southern basins are observing, anywhere from 25 to 75% of average snowpack. So that is really a function of December. The storms that we saw that brought the precip here were actually fairly warm.
Right.
They were lower latitude. One of them was one that was a closed low system that slowly wandered across northern Mexico, pumped up some really good subtropical moisture, but snow levels were very high. So we didn't get any accumulating snows out of those particular storms, but the precip was good.
Yeah, and that was actually a characteristic of those storms in California as well. And that happens when you bring moisture in from the tropics. You're also going to bring in that warmer air.
Absolutely. So there's you got this low latitude, long fetch from the subtropics. You're dealing with some dynamics that are still fairly warm on the southern part of the low pressure system. So they streamed in and dumped a bunch of precip across California, all the way to Southern California, and then down to Arizona, but snow levels were high. But this series of events, we're getting sort of deeper into the winter season. There's more cold air to interact with.
If you just look at the map of the West and look at the precipitation, the Pacific Northwest has experienced slightly below average conditions, whereas the rest of the West is above average for the most part.
Yeah.
That's sort of not what you expect.
No, the joke that's I think we've all been telling, again, funny to climatologists and meteorologists, is that this is the best El Niño impersonation we've seen in a long time, done by La Niña. Just looking at the early season totals here, November, December totals across the West, as far as precip anomalies, Pacific Northwest is dry, Southwest is wet. If you would have told me anything else, I would have bet $5 on it being an El Niño year.
In terms of the snowpack being important for the water supply, early stream flow forecasts for the Colorado River are looking pretty good too. So
isn't that interesting? It's flirting with shortage, and then this winter looked like the death knell for putting that into effect with below average winter precip, and here we are looking at this. Right. But man, it's January 20th.
Yeah, no, I know.
I've been here before. Well,
so
I've been so psychologically scarred that now I am.
Wonder what's going on with my psychology, right? Because now
you were the pessimist.
Now I'm optimistic.
I know.
It's going. And last year, of course, I was like, well, hold on, we ought to wait.
Exactly.
It's early. Part of it is it's hard to get precipitation here, and when you get it, you take it.
That is exactly the glass or rain gauge half full feeling with this. I don't know what it is. I want that back.
It would be interesting to see what it would take for us to just have an average year, given the precip that's occurred so far.
I hear you, man. This is where my pessimism kicks in. This reminds me a little bit of the winter of 2009 and 2010. And remember, you and I had a project on this. Remember, we were talking with FEMA? That was an El Niño.
There was a parade of Pineapple Express or atmospheric rivers that year.
Absolutely.
Right?
But it was an El Niño winter. It laid down all sorts of wonderful precip in December and January. And then do you remember what happened after that? February and March ended up complete shutdown, got very, very warm, very, very dry. This was the crazy season in Flagstaff that they had 10 feet of snow. They had by the end of January, Flagstaff had 10 feet of snow. They had issues with roof collapses across Flagstaff. By March, they had dried out so much, and by that spring, they actually had a fire. And the Schultz fire burned almost downtown Flagstaff, and then led to a subsequent a bunch of mudslides in the monsoon season the following summer. It's so classic Arizona, hitting the guardrails on both extremes.
You are right, Mike, that it's still early, but nonetheless, like I was saying about the stream flow forecast, they're calling for a 50% chance of it being 140% of average.
Yeah.
And there's even like small chances, let's say a 1 in 10, so really low probability, but still 10% isn't that bad for somewhere on the order of 13 million acre feet, which would be 4 million acre feet flowing into Lake Mead, more than historically what happens. And that would be a huge boost to those reservoirs levels, which are, sort of currently hovering around that magic number, at least in Lake Mead, of 1075. So that could help the urban and ag water supplies quite a bit.
I should be much more optimistic than I am right now. It's this thing of what would be an ideal sort of playing out over the rest of this winter, being January 20th, knowing that February and March are still big climate months for us here in the Southwest. That's where we should be building towards sort of our peak snowpack about March 1st. What we'd really like to see is a couple more good rounds of storms, broken up by some, mild excursions into some, warm weather here and there, but that we don't shut down, right? That we don't start to do what we've done the last couple of years, which is we start summer in March. And then we've done this weird thing with, and I do believe it's El Niño related, which will not be at play this year, is we do like, oh yeah, I forgot to do spring, so we do it in April and May. So we kind of like reversed it. We did that 2 years in a row, right? And that was also what did some of the weird streamflow catch-ups on the basin, was this late winter storm activity. So I think, El Niño's yielded. La Niña is effectively yielded. We're in neutral. So what's at play now? It's kind of the weather variability of the winter, the Madden-Julian oscillation, which is one of our sort of forecasting tools that on that 30-60 today can sort of govern sort of large-scale, hemispheric circulation, has actually been not at play for like the last 6 to 8 weeks. It's now gearing up. So I'd expect to see some more variability come up with that.
Madden-Julian oscillation flares up. Like, what does that mean?
What it's going to do, it's going to be these little pulses of convection and sort of rising and, a couplet of rising and sinking air that will, in the tropics, move all the way around the globe in about a 30 to 60 day cycle. And as it does that little couplet of rising and sinking air, it's going to perturb the jet stream in the mid-latitudes. And so for us. And so out of that, you can get a sort of coherent expectation of when you'll have sort of dry and wet periods or warm and cold periods at different spots of the globe.
So you would expect there to be some wet events associated with that.
Yep. And depending on where that couplet of rising sinking air is and where it's sort of parked or stalled or how quickly it's moving and where it is on the globe will then influence the jet stream pattern.
But the fact that there is an occurrence of it suggests that we'll see some downstream effects of it.
Absolutely. Yeah.
Downstream wet effects of it.
Wet and dry. Cold and warm. So, and again, it's all going to organize around the sort of jet stream pattern, right? I think it has to do, and again, my understanding of it is not complete because I've tried to sort of work through all of those, what they call these sort of anomaly maps. They have this idea of way of tracking it is these 8 quadrants across the globe of where that couplet is and then what kind of expectation of cold or warm or dry or wet you'll have in different spots. And they're stronger and weaker in different locations depending on where that MJO signal is. Right.
Okay.
So you already see that discussion coming out of some of the forecasters started saying that we see an MJO emerging in the forecast and we expect it to move this quickly and to be in this phase at this time. So then we would expect the patterns to sort out around that. It is not perfect because what it's already relying on is that the weather models have to see it correctly and have to move it correctly. But if it does hang together and it's a robust event, you can actually have a fairly reasonable forecast come out of it.
Let's do a different thought experiment. So, the last 30 days, last month has been really active here in the West. The conditions that led to that, I guess the question is, can they persist? And so maybe what's been going on here, if we can describe that. The picture that I've seen is that there's been this sort of low pressure system that's been parked off the Pacific Northwest that's helped sort of, and that sort of spins counterclockwise and that sort of helps bring moisture in to the west. And that was actually the sort of conditions that were set up for these atmospheric rivers that drove moisture in from the tropics and into across the West Coast. At that same time, we also had this sort of ridge over Arizona, which enabled, sort of funneled the precipitation more toward Northern California. And from those events that dropped, copious precipitation in California, didn't really deliver as much to Arizona for obvious reasons.
Yeah. They
did, however, help boost the snowpacks and the precipitation in Colorado and Utah. How do we maintain that sort of overall pattern to continue this sort of ferrying of these events into the West? I mean, can we do that?
No. All I can do is say no now. I know I want to give you an affirmation here, but
that's we can't continue to keep doing that.
And it's probably good. Right. I mean, because honestly, if you look at the collection of events that have brought us precip so far this winter season, is that they have not been the same mechanism over and over again. Right. There have been multiple different ways to get to it. If you look at the upstream too, there hasn't been super strong persistent patterns persisting. How many times did I say persistence there?
Couple.
The point being is that the pattern has been changeable. What we had was a couple of these events, we had really strong ridging over Alaska. Mm-hmm. And if you've got strong ridging over Alaska, you're going to get this responding trough to build over the western U.S. And so we actually had that. And we had a little low break off of that and a closed low that wandered across. That was actually a very important event because it gave us multiple days of precip and good precip. We've had lows that have tracked right out of the Gulf of Alaska and come over us. We've had interactions with cutoffs. We've had now what we're dealing with this week is we're dealing with a parade of storms on a strong subtropical jet. It looks a lot like an El Niño with a really strong low pressure trough over
So the
Alaska.
Jet is more coherent from the Western Pacific across the
it looks
the
a
Pacific.
lot like that weekend, that magical week in January 2016. Is it because of El Niño or La Niña? No, it's weather scale variability phasing and giving us this shot at a parade of storms.
If what you're suggesting is that there's been a lot of different sort of patterns and
lots of different good, juicy, different types of weather.
Right, and
patterns.
We know historically, based on the climate, that like this sort of good fortune. I should be qualified here when I say good fortune because the rain brought a lot of precipitation and damage. So.
Not to the Southwest.
Not to Arizona. No.
California did.
Right.
Yeah, they had some trouble. I mean, that's kind of the way they'll get it.
Right.
Is these storms that'll barrel in off the Pacific.
But I should temper that language.
Yeah, fair enough. I know we are total precip junkies down here in the Southwest, and not everybody feels as affectionate towards precip.
I do have a lot of affection for precipitation.
I think we do. Absolutely, and I think it's right.
It's just more interesting.
It's earned. It's earned living in an arid
cool
area.
Cloud cover.
Absolutely, clouds and
great light
and water. We need
water.
it.
We need water.
We need water.
Okay, so the converse though is how do we arrive at a scenario in which we shut off that sort of faucet?
It'd be some kind of blocking pattern, some kind of persistent ridge that would set up across the Southwest.
Not unlike what's happened in previous years.
February and March of last year was just, we couldn't steal a cloud during the middle of the winter season, right? And so I was looking at the weather maps for last year, and we did a lot of this sort of post-mortem on the El Niño event. We had a super strong, persistent Aleutian low, which is what you'd expect to see during an El Niño winter. But what you didn't see it as sort of deep and as expansive as we expected it to be in like 97, 98, and 82, 83. And so having that low in the Aleutians, that's that trough. What do you see on the east side of that? You see a ridge. So if that thing is cranking away and responding sort of the persistent, anomalous tropical convection, that all pumping along there, you're going to get the jet stream to kind of stick and get stuck in a spot and going to do that, dump a ridge on you. So what's been interesting here is that we don't really have strong, it doesn't really show up at least in the tropical Pacific. These clusters of thunderstorms, it's kind of moving all over the place. There's a lot of sort of competing signals now that have been shaking up the northern hemisphere and mid-latitudes weather patterns. That's given us a good shot at breaking into a ridge, breaking it down, getting a precip event. It's what you'd want to have in a winter, which is changeable weather patterns, not getting stuck.
Okay, so
so what was my forecast? What did I even say there?
Well, I don't know. I was trying to figure that out. I mean, I guess like you were saying, it could be either.
It's a coin flip now, and it's a coin flip. So it's funny. there's like a hint of optimism in saying that I don't necessarily expect a crazy, warm, dry, ridgy February, March of last year to emerge next month, because there's really no other element out there that would necessarily force us to get stuck in a pattern like that in the tropics. There's other stuff that's going on right now that I think is going to come to play. It'll be much more interesting at the higher latitudes. The polar vortex, the dreaded polar vortex, which was expected to kind of drift down off the poles many times this fall season, has stayed pretty strong and coherent and up around the poles, what we call about the Arctic oscillation. There's some expectation that it's now going to sort of splinter off and get shoved off the poles, which has maybe some implications for us here. But again, we're still kind of looking.
More so for the east.
East, absolutely. And there's already some forecasts now sort of calling for warm west, cold east pattern emerging next month.
Even with the sort of wet weather, Arizona in the last month has been pretty warm.
It has been. It's not been chilly. It's funny. It's felt chilly on those days that it rained. But if you look at the temps in between, the low overnight temps have been high. And we've had some fairly warm interludes between those periods as well. Well, I mean, if you look at December as a whole, and even early parts of January, I'm looking at some of the Tucson data here, is that we had half of the month had above average highs, 15, almost 20 days. Very few of those days, only 2 or 3 of them were below average for overnight temps. So that's a good way to build an above average there. It's those things that humans are such terrible climate recorders, because all I remember was that I got to wear my favorite fleece 4 times in December and then in early January.
Yeah, well, we remember the sort of the extremes.
And then we interpolate between them, and must have been like that every day. And I forgot that it actually got up to almost 80 degrees in the early part of this month, even though it was bookended by the beginning and the end now of these nice cold wet storms. So
talking about prediction, the one thing that is probably fairly robust to predict is temperature, and the models for the most part are calling for increased chances of warmer temperatures in coming months, which is what we've pretty much seen for the last ever since I've been paying attention to the forecast.
And that's
very few are for below average temperatures.
There's a little bit of trickery with that in the sense that the trend is clearly solid and strong. The statistics now lean that it's much more probable, based on the trend, to be above average. So you wouldn't forecast below average unless you had extraordinary evidence to suggest that you were somehow countering the trend. And in the Southwest, there's nothing here. The only thing that would have spelled to the forecasters, any forecasting group, that you should go below average for a whole season is that there'd be some remarkable weather pattern that would have persisted. It would have only really been an El Niño to even sort of push you back to average conditions for the winter season.
We probably don't expect the temperature when we fast forward to January or to December to look back and say that this was the warmest year on record, like it was this last year.
Yeah.
I think we don't expect that, and that's largely because we had, if not the strongest El Niño on record, it was, a top 3.
Totally. I mean,
and that pumps a lot of heat into the atmosphere. So when you look at it globally, you see that, and that's not going to be the case this year.
That global signal was high latitude, pole, Arctic amplification implications on the global temperature. It was absolutely El Niño and sea surface temperature parts of it. So it's a bunch of moving parts working in concert to give you that warmest year on record. But you're right. So the competing elements of it going into this year will be, again, high latitude. The temps in the high latitudes have been all over the place this winter.
Yes.
And a lot of that's the dynamics of the
a
Arctic
lot of
oscillation,
variability,
a ton of variability, and actually little warm and cold blobs of air moving all over the place. Alaska had some extraordinarily high temperatures, and is now this week having extraordinarily cold temperatures because of this sort of movement on there. But at the same time, Arctic sea ice is cratered. It doesn't resemble anything that it had before because it's actually new kind of ice. It's that punky kind of weak ice there.
Yeah,
so,
I mean, when you
the
look,
Arctic is different.
Yeah, when you look at the trends, when you just look at across climate and climate-related variables, there's a few variables that have clear trends. Temperature is one of them. Sea ice is another one.
Absolutely, and sea surface temperatures too. You got all that variability from year to year from La Niña. It's all of it's trying to sort of boil it down to what for Arizona New Mexico when we sort of think about this stuff is that, we're sort of trying to track the wintertime variability, and the stuff that's happening up at the high latitudes, is it going to matter for Arizona? Well, we've had situations where when we've had changes in the Arctic Oscillation, they have not through a first order forced the weather down here, but have cooperated with other weather patterns to give us exceptionally weird weather down here. When that polar vortex gets moved off of the poles with this Arctic Oscillation and it wobbles around, it sometimes can wobble around over the northern tier states. And if a low pressure trough comes along, we can get epically cold weather occurring, which is this weird sort of interaction with a warming climate and warming high latitudes that we can get this weird shift in. And again, it's very weak and super noisy for this far south, but it can be part of the equation down here. And that's where you're starting to see the forecast for the cold east, warm west pattern could be whole cold northern tier pattern, wherever that polar vortex sort of shifts off and how it interacts with sort of the jet stream pattern it's going to trace across the U.S. the next time. So, okay, here's a little bit of like perkiness from me. I think the next couple of months are going to be really, really interesting because we've got some new sort of signals emerging with the Madden-Julian Oscillation and this potential polar vortex shift with the stratosphere kind of getting into play and that kind of stuff.
What I did last year, I'm going to do again this year, which is I don't think it's not a forecast of persistence. And this is where I'm being a little bit pessimistic, but this is also how I view climate. I think it's easier to think about going the opposite direction of what just happened, particularly in the Southwest. And
that
particularly
sounds pessimistic.
Particularly if it's dry. I think it's realistic though. I mean, so I would expect that the weather conditions and the wet weather doesn't sort of uphold, and that's sort of we regress toward the mean, if you will.
I completely agree with you. So you're sharing my pessimism that these great times cannot continue.
Right. And I don't think they can continue, but I think my earlier optimism was just in reflection to the fact that, we started off really well. And when you start off really well, you're playing with house money.
You are a pessimist. That is so pessimistic, and I completely share it.
It's just climatology.
It's true.
That's all it is.
It is true.
It's like if you're low, you're optimistic because you're sort of regressing toward the mean.
I completely agree with you. I think this has been a really good run. Okay, so again, I'm trying to bring some science into this rather than...
I'm bringing statistics. That's science, man.
No, I think I agree. That's where I'm kind of going with this as well. What do we have to work with as far as thinking forward? We lean heavily on El Niño and La Niña.
Which this year, it's a weak...
It's gone.
Weak condition. It's gone for the most part.
It's gone. I think that we can say that it's gone. So we don't really have any usable signal, right? So now we're into Madden-Julian Oscillation, right? And that's the forecastable part of it. So the 3 to 4 week forecasts are basically for February now are showing a return of ridging to the Southwest, which quite honestly
doesn't bode well.
It does not bode well, but it's also perfectly reasonable,
right?
And makes a lot of sense because it is the fallback position
Warmer
for weather
conditions.
Patterns. It would warm up, it would dry out, but I also don't think that there's necessarily any reason to believe that it is more than a 1 to 2 week or persistent pattern, and that we still have room. Gosh, do you feel this? This is optimism coming out. Is that there's a couple more weather events that could shake out in late February and even in through March.
So we have the Madden-Julian Oscillation to work with. What else do we have to work with? We have climatology.
We have climatology, yeah. That more often than not, it does rain at some point in the Southwest in February and March. February and March.
That's the most brilliant thing we've said all day. That's sarcasm.
No, it's so, well, we've gotten back to
sorry, man.
Being tortured by the climate models and their lack of usable information.
What are the climate models saying?
Zach, that's a great idea. So if we just talk about the National Multi-Model Ensemble, the NMME has bounced all over the place, and what it's settled on is...
Are you talking about ENSO, or are you talking about
No, I'm talking about the average of the climate models and their spatial patterns, and you're going to look at it right now, is that it is a complete wash.
But in terms of precipitation?
Precipitation, yes. For the Southwest, they all cancel each other out. Half of them lean wet, half of them lean dry, and so it is there's no signal. And the calibrated forecast actually leans slightly wet based on, I don't know how that actually works.
There's 8 of these different models from different modeling centers that are all forecasting, climate variables such as, we're looking at precipitation rates.
It's the North American Multi-Model Ensemble.
There you
yes.
go. So I'm looking at these 8 different models, and Mike's right. There's, half of them are for Arizona, New Mexico, and the Southwest in general, calling for, drier conditions in the upcoming 3 months, and the other half or thereabouts is the other sign.
Yeah.
Do you have your pet model?
No, you never do that. You never pick one kid over the other. No, you love them all equally. That's just what you do.
Spoken like a true father.
Absolutely, right. They all have their own little quirks and idiosyncrasies.
It's crazy because they all cancel each other out. And so when you look at the multi-model ensemble, it's like there's no wet or dry conditions across.
You know what I take away
basically the western 2/3 of the continent.
Again, I think it's what we're kind of dancing around is that there's no coherent stuck signal somewhere in the global model that is forcing a persistent pattern. They're all sort of sorting out weather. It's basically the basis of all seasonal forecasting is you look for something that's slowly evolving in the climate system and you lean on it to say it's going to do something persistently over the next couple of months. There's nothing out there right now that works at that time scale.
But so what would there be? I mean, obviously it's ENSO's one, but is there anything else?
So this is where the cutting edge of the research is there's a meteorologist in the East named Judah Cohen who's done some really cool work on Eurasian snow cover in the fall and its interactions with the polar vortex and the stratosphere and the Arctic Oscillation to try to be able to do temperature forecasts that largely really only impact the eastern U.S. We just talked about the Madden-Julian Oscillation, which is going to be coherent variability that will progress around the globe at 30 to 60 days. What else do we have as far as forecasting? We have snow cover that can lead to temperature interactions. We sometimes use soil moisture in spring for temperature. But, we're talking the Southwest and we're talking about precip. It's really El Niño or La Niña. We now know that it can sometimes lead us astray.
If these climate forecast models that are forecasting, in this case, precipitation, are being influenced heavily by ENSO and there's no real coherence in what we're looking at in terms of precipitation, then that sort of means that there isn't a strong signal going forward in the current ENSO system. And that's kind of what we see. That is what we see, actually. And the forecast, I believe, now is for, ENSO's been borderline weak La Niña throughout this entire winter, and it's going to dip down, I believe, in sometime in February, right? That's what they expect, that it'll cross below that magic threshold and then, being more or less in a neutral event. And it won't be defined as a neutral event until subsequent months thereafter. But
right. So it doesn't look like it's going to make the cut. Think so?
Barely.
It's dicey, I think, right now. And I think that's been the discussion, has been that this is borderline. It might not make the cut. To me, what's fascinating about it was we came out of that super mega hyper uber El Nino from last year, and we were kind of looking at this deep cratering back into a La Nina event with 97, 98 as an analog, and it didn't happen. Yeah. The models really got wagged around by it.
I felt like that was mostly based on just a few events and the tendency for the system itself to have these sort of inherent like checks and balances that correct itself.
There was some science behind it, and a couple of the dynamical models, they went bonkers in that spring season last year, which I freaked out because I felt like I got cheated out of a winter, and then we were going to go into a super El Nino. Super La Nina the next winter, knowing you're going to get cheated again. And it's been so interesting that it really has not played out that way.
Right. But, some of these models are actually forecasting for potentially El Nino conditions, although I am saying that now with some hesitation. They're far, those are far out. So I think that is to be taken with a few grains of salt.
The Pacific Decadal Oscillation, the metric that we use for that, as far as kind of tracking North Pacific pressure patterns and sea surface temperature patterns, has been in the warm phase now for many months.
Since 2014, I believe.
2014. Bobbed along. It's all the monthly variability that you'd expect it to be, but it's got this lean to it now that is interesting. so silly to even talk about PDO because PDO is really only useful retrospectively and looking backwards going, oh yeah, did you notice that 20-year period was like this?
Like in terms of like statistical correlations, but really the dynamics and the influence of it is not well understood?
Absolutely. Well, yes and yes. The dynamics, it's probably a statistical representation of lower frequency variability, sort of averaging out weather frequencies over time.
But doesn't have any causal influence?
No, probably not. It's more reflective of what's been going on in the atmosphere rather than causing anything in its own right. But it's interesting. What if we're now in this sort of decadal variability phase where we've got, we're leaning more towards El Nino events. But it would be interesting as if like 5 years.
There is some talk, though, that the conditions in the North Pacific that's measured by the PDO does shade a little bit of the of the ENSO events, right?
The dynamics in what they call the sort of the atmospheric bridge between the tropics and the North Pacific are super complicated, and they have everything to do with the temperature patterns at different depths and the overriding weather patterns at the surface, and how you get these sort of recurrent and emergent patterns of sea surface temperatures across the Pacific that give you this PDO look to it. And at least what I've seen is that most of the studies suggest that what it's doing is it's sort of the slow integrator of all this ENSO variability in the tropics. So it's just telling you what you already know of what's already happened.
When you have more El Niños, for example, it has a different shade. The PDO has a different shade than when it has La Niña.
And so having a super El Niño followed by a weak La Niña that couldn't get its act together, followed by this trending towards El Niño again, you'd expect over time to start to say that the PDO is sort of like leaning, it's following you along saying, yeah, totally. It's not very La Niña-ish right now. It's more El Niño-ish. And so it doesn't tell us a lot, but it's sort of, from a historical analog perspective, dynamically, what is it that gives us more of this El Niño frequency that shifts more towards El Niños in a decadal pattern? Like, is that what we're headed towards now?
Can that influence local weather expressions, like the sea surface temperature pattern in the North Pacific? If it's colder or if it's warmer, can that then influence, let's say, precipitation in California, or perhaps the ridging that we saw in recent years? So wouldn't have this sort of big regional expression, but would be more confined to.
So it's interesting. You'll see interpretations of this in the weather forecasting community where they'll say, see that PDO pattern caused this jet stream to be stronger. The papers that I've read by the climate modelers who actually kind of go into the physics and the thermodynamics of it say that the temperature anomalies in the North Pacific are not strong enough to force any of the overlying weather variability, and that the patterns that you see in the sea surface temperature patterns are lagging expressions of the weather variability over top of it. But what you can have happen is like the blob, the warm water blob that was off of the Pacific Northwest that was really a result of strong, persistent ridging prior to the El Nino event emerging, started to influence the coastal temperatures because the coastal temperatures in that maritime air mass are in perfect concert with the sea surface temperatures. So sea surface temperatures are high, the overlying air mass is going to be warmer, then you can make a perfect prediction on temperature because you know exactly what it's going to do based on that sea surface temps. But other than that, I don't think that there's a lot of forecasting utility in it. This is one pessimistic climatologist perspective, though.
It comes with the territory.
Yes.
You should be actually even keeled, though. I think it's
I should be a median. I should be right on the median.
Exactly.
Right? That's funny. Is that like on a coffee mug? I should get that on there.
I don't think it's got a big enough market to make any money.
It's probably true.
All right, I think we should say our goodbyes to all of your fans.
Gonna wax my skis.
Yeah, it is gonna be great. Get a little snow on Mount Lemmon, and
you're bringing me out of my little. I'm feeling a little less pessimistic now. You've kind of helped talk me through this.
We'll see how things go in a month, and we'll come back in mid-February and do our normal thing. So thanks again for everybody for tuning in and saying goodbye from myself and Don Miguel.
Don Zachary.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA Program Manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, Research, Outreach, and Assessment Specialist with CLIMAS.
Should I be quoted on that?
No, I wouldn't. I wouldn't say that. We've done some kind of weird brain transference.
Yeah, I don't know.
How's it working out for you? It's working out well, I think, for you. It's good.